Hello everyone, welcome back to my YouTube channel. My name is Astha. I'm a fourth semester student pursuing my computer science and engineering degree in Sri Venkateswara College of Engineering. In today's video, we will discuss our topic of analysis and design of algorithm. The subject code is BCS 401. My USN is 1VE23CS001. Introduction to sorting algorithms. Sorting algorithms arrange items in specific orders. Example includes selection sort, bubble sort, merge sort, and quick sort. They improve the data management, organization, and search efficiency in databases and applications. In this video, we will be talking specifically about selection sort. Selection sort is a comparison-based sorting algorithm. It sorts an array by repeatedly selecting the smallest element from the unsorted portion and swapping it with the first unsorted element. This process continues until the entire array is sorted. It is simple and intuitive. That is, it repeatedly finds the smallest unsorted element. The array is divided into two sections, sorted and unsorted array, and stepwise sorting. It places the minimum element at the beginning of each round. So now let's look into the algorithm of selection sort. Step 1, start from the first element in the array, that is index 0. Step 2, find the minimum element from the unsorted part of the array. Step 3, swap the minimum element with the first element of the unsorted part. Step 4, move to the next element, that is index 1, and repeat the steps 2 and 3. And step 5, continue this process until the entire array is sorted. In this selection sort, a temporary variable t is used during the swap operation. When swapping two values, we need to temporarily store one value so it's not lost during the exchange. Therefore, we have used the temporary variable t. This way, both the values are exchanged safely without losing any data. Let us understand more about selection sort with the help of an example. The step 1 is we have to find the minimum number and we have to swap it with the first element. So in an array of numbers 11, 25, 12, 22 and 64, 11 is the minimum number. We will swap it in the first with the first element, which is already done. Next, we will find another smallest number and we will swap it with the second element. So another smallest number is 12. We will swap it with 25. The array becomes 11, 12, 25, 22 and 64. In step 3, we will find another smallest number, which is 22, and we will swap it with the third element, that is 25. So our sorted array becomes 11, 12, 22, 25 and 64. And this way our array gets sorted. Let us understand one more example. Let's take an array of numbers 20, 12, 10, 15 and 2. And start with the first iteration, keeping I is equals to 1. So I is equals to 1, j is equals to 1, and k is equals to 2 to 5. We have to check whether a of 2 is less than a of 1. A of 2 is 12 and a of 1 is 20. So 12 is less than 20, which is true. Therefore, j becomes 2. Next step, I is equals to 1, j is equals to 2, and k is equals to 3 to 5. Here we have to check whether a of 3 is less than a of 2. A of 3 is 10 and a of 2 is equals to 12. So 10 is less than 12, which is true. Therefore, j becomes 3. For the third step, I is equals to 1, j is equals to 3, k is equals to 4 to 5. We have to check whether a of 4 is less than a of 3 or not. A of 4 is 15 and a of 3 is 10. Therefore, 15 is not less than 10. This condition becomes false. So j continues to be 3. I is 1, j is 3, and now k is equals to 5. We will check whether a of 5 is less than a of 3 or not. A of 5 is 2 and a of 3 is 10. Therefore, 2 is less than 10, which is true. So j becomes 5. So we will take a temporary variable t and we will store the value of a of I, which is 20. That will be equal to a of j, that is equals to 2. And finally, T is equals to A of J, that is 20. So a new array for I is equals to 1 becomes 2, 12, 10, 15, and 20. Similarly, we will do the steps for I is equals to 2, I is equals to 3. But in this question, when we do for I is equals to 2, we get a final sorted array, that is 2, 10, 12, 15, and 20. Let us also look into the selection sort pseudocode. First, we need to understand what is pseudocode. So, pseudocode means a simplified, informal way of writing the steps of an algorithm. It is not the actual code, but it looks similar to the programming language syntax. It helps to understand the logic of an algorithm. It is easy to read and write without worrying about exact syntax, and it is used for planning before the actual coding. So in case of selection code, the first step is loop I from 0 to n minus 2. Iterate through array elements. Step 2, find minimum from I to n. Identify the smallest in unsorted portion. And step 3, swap minimum with array of I. Place the smallest element at the correct position. Complexity analysis. Best case, big O of n square, even if the array is already sorted, selection sort still compares every pair. Average case, big O of n square, it always goes through all the comparisons regardless of order. And worst case is again big O of n square, that is same number of comparisons for a reverse sorted array. Why big O of n square? The outer loop runs n times. The inner loop runs n minus I minus 1 times for each outer iteration. Therefore, total comparison is n plus n minus 1 plus n minus 2 up to n, which is equals to n minus 1 by 2, which is equals to big O of n square. Space complexity is big O of 1. No extra memory is used except for few variables, and limitations: slow for larger data sets, inefficient on big inputs. This means that the time it takes to sort an array grows proportionally to the square of the number of elements. Selection sort is also a memory efficient algorithm with a space complexity of big O of 1. Use cases for selection sort. First, small data. Ideal when data sets are small and manageable. Second, memory constraints. Works well with limited memory availability. And third, teaching tool. Great for teaching algorithm basics and sorting logic. Now let's look into some advantages and disadvantages of selection sort. Advantages: it is simple to implement, minimal memory use, and reliable on small lists. Disadvantages: inefficient for large data, quadratic time cost, and same steps to be followed even if it is sorted. Hence, we conclude that selection sort is simple and educational. It is great for small data sets and teaching sorting basics. Performance limit: not suited for large or nearly sorted data. Alternatives: we can use merge sort or quick sort for large scale tasks. And with that, we come to an end of our today's video. I hope that you guys found this video informative. If you do so, please do like, share, and subscribe to my YouTube channel. Thank you.